Welcome to our online class. My name is Mohammed Javed. I'm a mathematics teacher at Alfred International School and College. At this pandemic situation, our school has arranged this program so that you stay at home, be safe, and we use the time effectively and efficiently, because there is no lockdown to learning, there is no lockdown to knowledge. So you stay at home, be safe, and today I will cover a topic from geometry, that is circle theorem. There are at least 10 or 11 theorems that we will discuss for your O-level preparation. Theorem number 1, it is circle theorem. Theorem number 1, it says that angle subtended at the center of a circle is twice the angle at the circumference. What does that mean? This is a circle, this is the center of the circle, and AB is an arc. Now let us stand an angle on the arc. Starting from the A, it touches the circle and comes back. So this is the angle standing on the arc AB. Another angle which is subtended by this arc but at the circumference of the circle. Starting from here, touches the circumference and comes back. This is another angle. So let us name the angle. This is angle ACB, which is at the circumference, and this angle AOB, which is at the center. Angle at the center is twice the angle at the circumference. So let me mark this one with X and this with Y. Y will be is equal to twice of X. That is what the theorem says. Let me write the theorem. Angle at the center of the circle is twice the angle at the circumference. Let me give you one example. Suppose the value of X is 40 degree. Then what will be the value of Y? The value of X is 40 degree. Value of Y will be double of it. It will be 80 degree. Reason is this one. So this is theorem number 1. Now I will show you I will define theorem number 2. All are based on circle theorems. There will be circle and all the theorems will be on circle. Now theorem number 2 says that angle on the same segment, theorem 2, angle subtended on the same segment of the circle are equal. Now, first thing that you have to be clear, what do we mean by segment? If I draw a line with AB, this line is a chord. The straight line is a chord, and this part of the circle is known as segment. So the theorem says that angle on the same segment are equal. So let us draw the angles. Starting from A, touching the circle, coming back. This is an angle. Another angle. Starting from here, touching the circumference, coming back. Another angle. Starting from here, touching the circumference, coming back. All the angles are standing on this segment, or we can also say in the same arc. This is the arc. Or we can say on the same chord. AB is the chord, and all the angles are equal. So let me mark with X, Y and Z. And we can say that X is equal to Y is equal to z. This is what the theorem says. This is theorem number 2. Angle on the same segment of the circle are equal. Suppose the value of this y is given 30 degree. Then the value of x will be 30 degree and the value of z will also be 30 degree. Theorem number 2. I hope it's clear. Now I am going to theorem number 3. Theorem number 3 says that angle subtended on a diameter of a circle, I hope you know what is diameter. Diameter is twice the radius. So angle subtended on the diameter of a circle, theorem 3. On a diameter of a circle is 90 degree. Or in other cases, in many cases you will see that angle on a semicircle. In many books they write like this. Angle on a semicircle is 90 degree. So let us join this one. If a line passes through the center and touches both the part of the circumference, that is the diameter. O is the center. AB. So AOB, the whole line is the diameter. OA is the radius. OB is the radius. Now let us draw an angle on this diameter. Starting from here, touching the circumference and coming back. So this angle, let me name this angle, angle ACB. Angle ACB is equal to 90 degree. You know why? Because this angle, this is straight line, this angle is 180 degree. And we know that angle at the center is twice. So circumference angle will be half. So if this is 180 degree, this is half of it, is 90 degree. If I draw more angles, starting from here, touching the circumference, coming back, is angle ADB, that is also 90 degree. So reason is that angle on a diameter or angle on a semicircle is 90 degree. Theorem number 3. Now theorem number 4. Theorem number 4 is regarding a cyclic quadrilateral. So first, before that, what do we mean by cyclic quadrilateral? Quadrilateral, you know that it is a four-sided figure. If you place a four-sided figure inside a circle, then that is a cyclic quadrilateral. Let me show you one cyclic quadrilateral. Start. So this is a four-sided figure which is inside a circle, and it is a cyclic quadrilateral. So the theorem says that sum of the opposite angles of a cyclic quadrilateral is supplementary. It means that if we add the opposite angles of a cyclic quadrilateral, it comes 180 degree. So I am writing the theorem here. Sum of the opposite angles of a cyclic quadrilateral is supplementary. So angle A plus angle C if I add, that is equal to 180 degree. Proof is not in your syllabus, so I will show you the proof of this one, but it's not in your syllabus. Just you have to know the theorems in IGCSE, Edexcel, and implement to solve the problems. But it is better if you know the proof, it will help you. So A plus C is 180 degree. This is why, because sum of the opposite angle of a cyclic quadrilateral is supplementary. Again, B plus D is equal to 180 degree. The same reason, sum of the opposite angle of a cyclic. If you want me to prove this one, so let me prove this one. The proof is very easy. Let us join the center. Let us join this one. This is the center O. Now let us name this angle as X. And that part of the circle we are naming it as Y. Now see, this is the angle at the center. This is twice of A. X is equal to twice A. Because in theorem number 1, I taught you that angle at the center is twice the angle at the circumference. So that is implemented here. Again, I can say Y is equal to twice of C. Same reason. Angle at the center is twice. Now let us add left hand side and right hand side. X plus Y is equal to twice A plus twice C. Now can you tell me what is the value of X plus Y? This is a complete revolution. We know complete revolution is 360 degree. So it is 360 degree. And if I take 2 common, A plus C. So if you divide it with 2, we get A plus C as 180 degree. So see here, A plus C is equal to 180 degree. Similarly, we can prove that B plus D is equal to 180 degree. If you join from this side and from this side, similarly we prove that one. So theorem number 4 says that sum of the opposite angle of a cyclic quadrilateral is 180 degree. Good. Now we move to theorem number 5. Theorem number 5 is again on cyclic quadrilateral, but it has an exterior angle. See, there are 4 interior angles. It says something about exterior angle. Now what is the exterior angle? If I produce this line BC, if I produce this line, then this angle outside the interior angle, if I produce that angle is known as exterior angle, E1. Right? And if I produce this one, CD, this is another exterior angle. Now what does this theorem says? Theorem number 5 says that exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Interior opposite angle or opposite interior angle. What does that mean? It means that this is the exterior angle and the interior angle is this one, and the angle opposite to this one is this one. So E1 is equal to A. Exterior angle is equal to interior opposite angle. If we take this exterior angle, this is the interior angle, isn't it? And the angle opposite to this one is this one, B. So E2 is equal to B. This is what this theorem says. If you ask me to prove this one, the proof is also again easy. Let us prove this one. Proof is not needed. but I'm showing you here. E1 plus C is equal to how much? 180 degree. Why? Because sum of the angles on a straight line is 180 degree. And A plus C is equal to how much? 180 degree. Why? Because just in theorem number 4 I taught you sum of the opposite angle of a cyclic quadrilateral is 180 degree. Now both are 180 degrees, so I can write E1 plus C as A plus C. If I cancel C from both sides, E1 is equal to A. So this is what the theorem says. The exterior angle of a cyclic quadrilateral is equal to interior opposite angle. I hope it's clear. Another example, E2 will be equal to B. So if the value of this angle is suppose 70 degree, the value of B will be 70 degree. And if the value of A is 65 degree, the value of E1 will be also 65 degree. Understood? Now I am moving to theorem number 6. Theorem number 6 deals with a chord. Now you have to know what is a chord. Chord is a line that touches the 2 points of a circle. The line touches the circumference. Let me rub this one. So we discuss regarding chord. The theorem says that if we draw a perpendicular from the center to a chord, you know what is a perpendicular? The line that makes 90 degree with the base. That is a perpendicular. So let me write the theorem. Theorem number 6. A perpendicular drawn from the center of a circle to a chord bisects the chord. So now what does this theorem says? I'm explaining you. Let us join AB, and this is a chord. This straight line is the chord. And if I draw a perpendicular from the center, this is the center O. If I draw a perpendicular from here, this is the perpendicular. This is the perpendicular. So OM is the perpendicular. So if it says that if OM is perpendicular to AB, then AM is equal to MB. Understood? Let me show you the proof also. Let us join this one. And if I want to show you the proof, actually these two triangles are congruent. How? See, if we take these two triangles, AO, in these two triangles, in triangle OAM and triangle OMB, what happens? This side and this side, they are equal. OA equal to OB. Why? They are the radius. The plural form is radii. And this angle is 90 degree. Angle OMA is equal to angle OMB is equal to 90 degree. And this side is common. OM is common. So the triangles are congruent. When the triangles are congruent, they are equal in all respect. The sides are equal, the angles are equal. So we can say AM equal to MB as they are congruent. The reverse of this theorem is also true. Reverse means if we join the midpoint, then we can say that that is a perpendicular. The reverse is also, or the converse is also true. Now we start theorem number 7. Theorem number 7 is regarding a tangent. You know what is a tangent? A line that touches a circle at only one point, that is a tangent. Now if I write a name ATB, so this is a line. ATB is a line. It touches the circle at only one point, and that point is T. So ATB is a tangent. If I draw a line over here like this, that will not be a tangent. A line that touches the circle at only one point, that is a tangent. I can draw a tangent over here. I can draw a tangent like this over here, no problem. Now the theorem says that angle between tangent and the radius is 90 degree. So the angle between the tangent and the radius, so from center if I join, and it should touch at the point of contact. This is the point of contact. So if I join this one like this angle OTA, it should be at the point of contact. If you join from O to this point, that is not a 90 degree. So angle between tangent and radius, we should say at the point of contact is 90 degree. At the point of contact is 90 degree. Is 90 degree. So angle OTA is equal to angle OTB is equal to 90 degree. Why? Because this is the shortest distance from the center to this point. This is the shortest distance, and shortest distance is the perpendicular distance. So this angle is 90 degree. Angle OTA and angle OTB, they are 90 degree. This is theorem number 7. Now I will move to theorem number 8. And theorem number 8 is regarding a tangent, but a pair of tangents. We will draw two tangents to a circle. And then what happened? That I will discuss. Let us draw a pair of tangents to a circle and see what happens. So this is theorem number 8. Theorem number 8 says that if a pair of tangents are drawn to a circle, so let us draw a tangent over here. So this is the point P and this is the point O. Let us name this one as T1, T2. The theorem says that if a pair of tangents are drawn to a circle from an external point P, then we have three things to prove. The tangents are equal in length. Let me write this one. If a pair of tangents are drawn to a circle from an external point P, then what happens? The first one is tangents are equal in length. Tangents are equal in length. So tangents are equal in length means P T1 and P T2, these two lengths are equal. So we can write P T1 is equal to P T2. Second, tangents are equally inclined. Suppose inclined something, if I place something like this, the angle it forms, that is the inclination angle. So it is equally inclined, the slope are equal. Tangents are equally inclined. It means, let us join from here, center, from the center. This angle and this angle, they are equal, equally inclined. So OPT1 angle OPT1 is equal to angle OPT2. You can remember like this. Option 1 equal to option 2. These two angles are equal. Option 1 is equal to option 2. Why they are equal? I will show you the proof. Just keep it in your head, these three things. The line PO bisect the center angle. Line PO bisect the center angle. Now PO is the line from the external point to the center, and that line bisect this angle. So from here we learn three things. If we draw a pair of tangents from an external point P, then tangents are equal in length, equally inclined, and the center angle is bisected. So PT1 is PT2 equal, OPT1 equal to OPT2, and pot 1 equal to pot 2. So we have learned this one. From your book you see that there are many problems on circle theorems, and in your book I think there is exercise 10, 11, 12. So there are many problems, you can solve it, and from also chapter wise question paper you can solve the problem on circle theorem. There are few more theorems are there that we will cover next time. I hope by this time you got a good support from these 8 theorems. So practice your problems, and we will continue from here next class. Stay at home, be safe. Allah Hafiz.